Okay, let's have a look at question 8 in the discriminants worksheet. And this one here, it says we've got two equations. Here they are. I'll rewrite them actually. Y is k times 2x squared plus 1. And we've also got y is x squared minus 2x. So these two must be simultaneous if the y values are both the same. So y value means this, y is this, so therefore this must be equal to this. So I'm going to rewrite those again, and I'm going to then substitute the
coefficients into the discriminant function, so we can then go ahead and work out where these two touch, where they meet. Yeah.
So let's have a look at doing that now. So first of all, I'm going to make this equal to that. Here it goes. I've got a k 2x squared plus 1 is equal to x squared minus 2x. So I'm going to expand this out, by the way. Let's call this 2kx squared, and this is going to be plus k is equal to x squared minus 2x. I'm going to subtract x squared from both sides. Here we go, minus x squared. I'll rewrite this out. In fact, I'll put the x squared next to the x's over here because we want x squareds all together. It's got 2k x squared minus x squared plus k is equal to negative 2x. Well, let's do the same thing over here because I'm going to have to add 2x to both sides, and I'm going to now keep all the x's together. So because I'm looking for coefficients, so let's rewrite. So I've got to have a 2kx squared minus x squared. I've got a plus 2x, and I've got a plus k on the end. All right, well, this seems pretty good. All right, so I'm now looking for coefficients. So really, we've got coefficient here for x squared, coefficient for x, and a coefficient for x to the 0. So, and you could rewrite it that way if you want, but let's go ahead and actually tease out what the coefficient for x squared is, because I'm going to take the x out of here and just kind of factorize that little bit there. So x squared and factorize it. Well, what times x squared would make 2k x squared minus x squared? Well, k, in fact, 2k times x squared would be 2k x squared. And what times x squared would be negative x squared would be negative 1. In other words, if I expanded that out, I get this. If I expanded this out, I'd get that. Now I've got plus 2x, that's great, plus k. And really this is like x, so this is the coefficient of x squared. This is the coefficient of x to the, if you like, x to the 1. If you like, this is the coefficient of x to the 0. Of course, x to the 0 is 1, and 1 times k is k. So you don't need to write this in. You can just ignore that. So let's rewrite this now. We've now got the coefficients. In fact, the a value, the coefficient of x squared, is going to be 2k minus 1. There it is. The coefficient of b we've got is 2. The coefficients of c we can see is k. Oh, what am I doing? Don't need equals 0 on that one. All right, let's go ahead now. Put that or bung it into the discriminant function, which is 4ac. And we know it's going to be, in this case, what are the parameters said? Touch. If it touches, it said, look, must touch each other. So if it touches, then it must equal 0. All right, so b squared minus 4ac is equal to 0. I'm going to try and keep the symbols under each other if I can, although I think that's going to be a little bit difficult because the way I've written it, because I'll need a bit more space on this side. B squared, that's going to be, b is 2, so I got 2 squared minus 4 times a, which is going to be 2k minus 1, times c was k, is equal to 0. I'm going to rewrite that actually. I want the negative 4 and the k next to each other as coefficients for this thing here. So let's go ahead and do that. So 2 squared is 4 minus 4 times k is negative 4k times 2k minus 1. Now, whatever you do, don't be tempted to think, oh, this is a quadratic. Am I going to put brackets around here? No. This is the only bit that's actually multiplied. This thing here is the only bit that's multiplied by everything here. This just sticks out on its own. It's got really plays no part. All right, let's see if we can resolve this a little more. So negative 4 k times negative, it's going to be negative 4 2s are 8. K times k is k squared. And negative 4k times negative 1 is going to be plus 4k. And all that, of course,
is equal to 0. All right, let's take the next step. So I'm going to divide everything by 4, actually. Divide this by 4, divide this by 4, divide this by 4, and divide this by 4. I like doing that. So this is... Okay. So what have we got here? Well, 4 divided by 4 is 1. I've got a minus. In fact, let's make it negative. We're going to divide everything by a negative. Divide this by... If I divide it by negative 4, look at that. Because negative 4, okay, that becomes negative 1. But this becomes positive 2k squared. And this becomes, negative, that's a minus k, yeah? We've got a negative k is equal to 0. So I'll rewrite this a little bit more succinctly. 2k squared minus k minus 1 is equal to 0. All right, so now we've actually got a bit of a quadratic, yeah? In fact, we're going to be able to find the critical values here. Because if I said, well, 2 times 1 is 2, in fact, a little sidebar here. So 2 1s are 2, so the factors of 2 are 2 and 1. So here they are, quadratic, got a 2k here, and a 2k here. Signs are different. The biggest one's going to be negative, so that must be a 2, that must be a 1. Can factorize that or divide that by 2. So it's 2k plus 1 and k minus 1 are my factors. So that all comes to a 0. So what are the critical values of k here? So we can say either, in fact, I'm going to do this up above here because we're going to run out of space here a little bit. So we've got, I'll rewrite it, we've got 2k plus 1, and we've got k minus 1 is equal to 0. So either we can say k is equal to 1, or we can say k is equal to negative 1/2. So they're my two critical values. In this case, because we're writing, we're not really so much dealing with the parabola which we saw in question 3. Well, you could draw it like that if you want, but we're dealing with just two values, not a range of values. We're saying, what are the values where this is true? What is the values where these two equations touch? And they touch at k is 1 and negative 1/2. So if you were to throw in here either a 1 into here or a negative 1/2 in here, these two would be simultaneous for those points. And those points, they would touch at 1 point using those two values. And our two values, these, and here they are. So you can call these our critical values if you like. Or I would just say these are the points. If you go back to the original equation, you probably should actually write out what it says here. So you want to say when k equals 1 or negative 1/2, the two equations touch. It's just touch. I'll put touch. Sorry, you can't see that. So that's what I've written here. Yeah, the two equations touch, and that would be. Don't write anymore. Just write that. I think you're on safe ground.